Okay, question 6. And, surprise, surprise, the first question is a definition question. So, this is a horrible definition, but the other ones were actually pretty straightforward. So, Doppler effect is quite often asked as a definition in this section because it's only it's grade 12 work. So they often ask it. But anyway, if you could try and study it, please. But you lose a mark for not having the words that are underlined if you're missing any of those words, so that doesn't make sense. Okay, so 6.1, state the Doppler effect. 6.2 is use the information given to calculate the speed of sound in air. So there's a Terry table for this one. I don't know how you feel, but it's VL and VS. And then there is towards and away. And the formula is FL is equal to V plus or minus the VL over V plus or minus the VS FS. And L is the listener or the detector or whatever machine they're saying they're using to measure the frequency. And S is the source. It's the thing that's making the noise. So mathematically, and anyway, I can just... If the VL is moving towards, it's a plus. And if that one's a plus, that one's a minus, that one's a plus, that one's a minus. So just by learning any one of those four, you can derive the other three, which I always think is beneficial. So rather than trying to learn all four, you can just learn any one of them. And so now for this thing, stationary listener, which means that VL is 0. When the car is traveling at a constant velocity of 26, so VS is 26, and it approaches the listener. So that means that this one at the bottom needs to be minus, towards VS minus, so that one at the bottom needs to be a minus, and the recorded frequency is 615. So the detected frequency is 615. When the car passes the listener and moves away, so if the VS is moving away, so then you have another set of things. VL is equal V plus or minus VL over V plus or minus VS, FS. You now have VL is still 0 because it went past the listener, and the recorded frequency is now 526 hertz, and you would now need to have a plus sign at the bottom with the 26. So this number you have, this number you have, this number you have, this number you have, this number you have. We need to solve for the speed of sound, which is a bit weird. We normally get given that is 340. But now you have a simultaneous equation. I don't know how you feel about it, but basically, mathematically, you can say that this is y. If it makes you feel any better, I don't know. And that is x. You have two equations with y and x in them, and you need to solve for x and y. So that's what they're going to do here, but the maths is going to look really scary because they're just going to do it like immediately without even showing you much. But they got 333.33. You know the answer to be 340-ish, so that makes sense and that's comfortable. So what they did here mathematically is perhaps a little bit scary, but, and again, please, just write the formula from the formula sheet. So don't do this other nonsense. Don't do this. Just write the formula from the formula sheet and you will get a mark for it. You will get a mark for choosing the correct formula. Then you get a mark for just subbing in the numbers. You get a mark for just subbing in the numbers, which is this nonsense that I did down here. Then you get a mark for making them equal to each other. So you get a mark for writing the formula from the formula sheet, and you get 2 marks for just putting in numbers. That is 3 out of 5, that is 60%. You can get 80% by just making them equal to each other. You really need to take part in physics. Write the formula from the formula sheet. Do not use your brain, use the formula sheet. Put numbers that you are given in the question into the formulas, and then you can solve for, well, you don't have to solve for. That's the thing. So if you can just do what you're supposed to do, they will give you marks for just doing what you were supposed to do. We do not mark your maths. So you can get 80% for that question without touching your calculator. And you think I'm joking or whatever you think, but this mark is for the formula, this mark is for putting in the numbers, this mark is for putting in the numbers, and this mark is for making them equal to each other. No calculator. 0 calculator is needed for any of those steps. So, yeah, you guys really, physics, we can't fail physics. Chemistry, you have to study a bit, but physics, really, you got to. I'm not sure you're going to, but you please. Okay, anyway, so then for 6.3, for 4 marks, they ask you to solve for the wavelength of the sound. They're asking you to solve for Fs. So basically, you take your answer that you got for 6.2. So if you didn't get an answer, you can just write there V equals 340, because you know it to be 340. You sub it into the equation that you made over here. So with or without it being correct. Sorry, not that equation. Where's one? Oh, come on, Terry. This equation. Sorry. You sub it into this equation. So whatever answer you got, whether or not you touched your calculator, you could just say 340, sub it into there, and so sub the answer that you got for this one into that equation and get an answer, and you will get marks for doing that. So you see here, you get the tick for subbing your number in. Then you get a mark for the formula, which you got off the formula sheet. Then again, you're subbing in your own answers that you got previously, and then you'll get the wavelength, and here is the range for your answers. It's really not too bad. We just need to get the formulas from the formula sheet, sub in the numbers, the ones that are given to you, all the ones that you've created, and then without even touching your calculator, you can get the majority of the marks, because this is not a maths exam. We don't value answers that much. We value that you know what you're doing with the numbers that we gave you. It's applied maths. You need to be able to do stuff with the numbers that you're given. Then, this is a bit weird. They're asking you to sketch a graph of the detected frequency versus time. So you've got 2 options here. I hope that you've at least seen a graph like this in life when doing Doppler examples. The car was coming towards, so it was higher, and then it was away, so then it was lower. And in between, you can either teleport, which is a bit strange, or you can just make this a little bit skew. So this little piece here is while you were driving past. So what you need in order to get the marks is horizontal lines here and here, because the frequency is constant while you're driving away and while you're driving towards. And the one after is smaller than the one before. And time 1, they asked you to label it. That is when it changes from higher to lower. So you can get 3 marks, and I do think that that's a fairly simple graph. It's easier than you would have gotten in vertical projectile motion anyway. So that was actually quite a nice question, I thought. And I haven't really seen it before, so I'm glad that we got to go through it now, because maybe they'll try something spicy like that this year.